Hello there, and welcome. I'm so glad you're here. Maybe your body is finally sinking into stillness, or maybe your mind is looking for something gentle, strange, and endless to wander through. Whatever brought you tonight, it's enough. You're here now. Let your breath deepen. Let your muscles uncoil. Let the quiet settle in like starlight over dark hills. There's nothing you need to hold on to, except curiosity. Tonight, we're not falling asleep from the world. We're falling asleep into it, into the vastness of where we are. A spiral galaxy spinning through darkness. A city of stars. A mystery we're still trying to understand. Because this isn't just a story about space. It's the story of your cosmic neighborhood, the Milky Way. Breathtaking, beautiful, strange. You'll hear facts that sound like science fiction, numbers too big to measure, objects too dense to see, questions still unanswered. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Out beyond the soft dome of your ceiling, beyond the roof, beyond the sky and clouds and circling satellites, lies a city of stars, the Milky Way. Vast, coiling, ancient, a spiral galaxy adrift in space, one of hundreds of billions, and yet, somehow, the one that feels like home. We live inside it, wrapped in its dust and light, cradled by its arms. From here, we cannot see its shape. We can only guess, infer, trace it like cartographers mapping a mountain range from inside a cave, but we know enough to wonder, enough to feel the edges of something immense. Our address, if written in cosmic terms, would not list a street or a town or a country. It would say this: Orion Spur, Milky Way Galaxy, Local Group, Virgo Supercluster, Laniakea. The Orion Spur is where we live, a small, quiet lane between grander galactic highways. It's not a major spiral arm. It's more like a side street, tucked gently between the Perseus and Sagittarius arms. Not especially bright, not especially crowded, just enough. Maybe that quiet is why life had the time and calm to rise at all. The galaxy itself is enormous beyond ordinary comparison, more than 100,000 light-years across, a scale so large that if you could fly at the speed of light, it would still take you over 100,000 years to cross from one side to the other. That's not a circle you could ever walk, or even imagine walking. It's not a place you travel across, it's a place you drift within. The Earth orbits the Sun in 1 year. The Sun orbits the galaxy in about 230 million years. You are moving, even now, but you will never make a full loop in your lifetime. No one does. Even entire species, entire civilizations rise and fall without completing one galactic turn. And yet, for all its scale, for all the fireworks of star birth and death happening across its length, most of the Milky Way remains invisible to you. When you stand outside beneath a dark sky, far from cities and their noise, you may see a few thousand stars. On a good night, perhaps 5,000. To your eyes, that seems like a river of light, an ocean. But it's only a droplet, just 0.00003% of the stars that actually live here. The rest are too far, too faint, or hidden behind curtains of interstellar dust. Even the pale streak of the Milky Way, that hazy arc you see stretching across the sky on moonless nights, is not the galaxy itself. It's just the thinnest inner thread, like a single thread in a woven tapestry you can never fully unfold. The galaxy doesn't sit flat. It's bent, warped, like a record left too long in the sun. That distortion may be caused by nearby satellite galaxies tugging gently at its edges, or by clumps of dark matter invisible to our eyes but heavy with gravity. Our solar system lies not in the center, nor at the edge, but about halfway out from the middle. We are in the disk, the flat, spinning plane, but we're not in the thick of the property. Spiral arms. We're in the quiet space between, a neighborhood called the Orion Spur, calm, unassuming, home. And perhaps that's a good thing. Spiral arms are dazzling, full of young stars and stellar nurseries and bright clusters. But they're also turbulent. Supernovae are more common there. Radiation flares more intense. In the narrow gap where we drift, conditions are a little gentler, a little more stable. Life, as fragile as it once was, may have needed that. From our vantage point inside the galaxy, we can't see it from above. We can only look along its grain. It's like trying to understand the shape of a forest from deep among the trees. The stars blur into one another. Dust hides entire regions. We have only maps, models, and glimpses from infrared and radio telescopes. And yet we know that the Milky Way is a barred spiral, a central bulge with arms that twist out and around like ribbons. There is a bar of stars crossing its heart, glowing faintly, rotating slowly, shaping the structure around it like a stone in the center of a whirlpool. The local group is our galaxy's larger family. More than 50 galaxies bound together by gravity, drifting together through the darkness. The largest among them are the Milky Way and Andromeda, each with their own retinues of satellite galaxies. The small and large Magellanic Clouds are among ours, faint companions that may only recently have been pulled into our gravity. Andromeda is getting closer every year. One day, it will collide with us, slowly, quietly, elegantly, but that is still billions of years away. For now, we spin. For now, we drift. We live in a quiet suburb of a violent universe. Elsewhere, galaxies crash into one another, tear each other apart, and birth new stars from the chaos. Supermassive black holes devour matter and flare with X-rays. Clusters of galaxies collide on unimaginable scales. The cosmic background hums with energy from the Big Bang. But here, in our little corner, there is stillness, or at least something that feels like it. But don't mistake quiet for simplicity. This suburb, too, has its mysteries. Dark matter surrounds us, invisible and unyielding. Magnetic fields thread through the disk. Stars are born and die. Clouds collapse. Planets drift alone. Even here, even in this gentle place, the galaxy is alive. When you look up, you are not looking out at the galaxy. You are looking into it. You are inside it, part of it, moving with it. Every atom in your body came from this place, from ancient stars that lived and died and scattered their elements into space. You are not just in the Milky Way. You are of the Milky Way. And right now, as you breathe, the planet turns. The sun carries you in a slow arc around the galactic center. The stars appear to shift, not because they move, but because we do. Everything is in motion. The galaxy is not a painting. It's a river, and we are floating in it. The sky you see at night is a keyhole view, a soft shimmer across a canvas of dark stars scattered like fine grains of salt. Familiar constellations anchored by memory or myth. You might count a few dozen without trying, maybe a few hundred if the air is dry and the lights are far away. But even on the clearest night, under the darkest sky, your eyes will only ever see a few thousand stars. That's it. A few thousand pinpricks of light, delicate, ancient, flickering from the distant edges of time. And yet, they are only the faintest whisper of what surrounds you. The Milky Way is filled with stars, so many that even saying the number feels like an exaggeration. Astronomers estimate between 100 and 400 billion stars in this galaxy alone. That's a range so wide it barely feels like a number at all, but more like a shrug in the dark, an admission that there are more stars than we can count, more than we can measure, more than we can name. Every one of those stars is a sun, many with planets, moons, storms, seasons, gravity, many with stories we'll never hear. The Milky Way is crowded, brimming with stellar bodies, and you will never see almost any of them. Most stars are hidden, not because they aren't there, but because the galaxy is made of dust as well as light. Vast clouds of fine interstellar grains drift between the stars, built from carbon, silicates, and frozen gases. These dust clouds, cool and dark, absorb and scatter visible light, turning entire regions of the galaxy opaque. The brightest clusters, the densest regions of star formation, the beating heart of the Milky Way, all buried behind cosmic curtains. In photographs, these areas appear as shadows, black rips in an otherwise starry sky. But they are not empty. They are full. Many stars are too far, their light stretched thin across distance, their brilliance dimmed to invisibility. Others are too cool, glowing not in visible light but in the red and infrared, slipping past your sight entirely. Some are tiny and faint, red dwarfs, the most common type of star in the galaxy. These stars burn slowly, sometimes for trillions of years, giving off just a fraction of the light our sun does. There are billions of them, maybe more. They fill the spiral arms, they move in gentle arcs, they pass unnoticed. You could live your whole life beneath one and never know it was there. Even the stars we do see are not necessarily nearby. Light travels at a finite speed, fast but not instant. What you see in the night sky is not what is, but what was. Every star is a message from the past. Some are hundreds of years old, some thousands. A few, like the ones at the far edge of the visible band of the Milky Way, are tens of thousands of light years away. You are looking back in time, always. The present is hidden behind the years it takes for light to cross space. But the galaxy glows in more than light. It hums, it burns, it whispers in frequencies your body cannot detect. If your eyes could see beyond the visible spectrum, the night would look like a storm. The Milky Way shines fiercely in radio waves, long, slow signals emitted by cold hydrogen gas and spinning electrons. In radio, you can see the structure of the galaxy, its arms, its warp, its heartbeat. Dust becomes transparent. The core is unveiled. In infrared, the glow of warm dust and newborn stars fills the darkness. Clouds that seemed black now flicker with hidden fire. Stellar nurseries blaze. The spiral arms brighten. The disk thickens with unseen activity. In X-ray and gamma ray, the galaxy is almost unrecognizable. The smooth swirl of stars becomes jagged, violent. These are the frequencies of death and transformation. Collapsed stars, black holes, neutron stars, all emit high-energy radiation. Flares, bursts, magnetic fields so strong they bend space. In these wavelengths, you see the scars of ancient explosions, the bones of stars that lived and died long before Earth had oceans. And still, most of it remains hidden. Even with our best instruments, our deepest maps, our most sensitive telescopes, we are only seeing a fraction of what the Milky Way contains. The dust still blocks, the distance still dilutes, and the galaxy is so large, so layered, that every discovery seems to reveal another veil behind it. Some stars wander alone through the galactic halo, faint and cold, untouched by light. Some drift through the thick disk, too far to catch even a glimmer of their presence. Many lie behind one another, stacked in tangled paths. We see the brightest on top, the rest are lost in the weave. And yet, we live in this place, in this unseen cathedral of stars. We orbit a single, ordinary sun that seems special only because it's ours, but is just one of hundreds of billions. We build our calendars by its light, mark our seasons by its angle, live our days by its warmth. But out there, surrounding it, are so many others, each burning, moving, aging, giving light to their own skies. Most of them will never be touched by a spacecraft. Most will never be photographed. They will shine and fade without our notice. The galaxy is not silent, and it is not dark. It only appears that way because of how narrow your senses truly are. Your eyes see less than 1 octave of the electromagnetic scale. Your ears cannot hear the low hum of radio emissions. Your skin cannot feel the passing of neutrinos or the burst of gamma rays, but they are there, always. The Milky Way is singing. You simply weren't built to hear it. Still, we try. We build machines that extend our senses, that capture invisible light, that translate the universe into maps and colors and sounds. We send radio telescopes to quiet valleys. We launch satellites above the atmosphere. We listen with arrays spread across continents. And when we look through these artificial eyes, we see a galaxy alive with motion and energy. A place more chaotic, more beautiful, and more full than we ever imagined. Tonight, as you sleep, tens of billions of stars are turning above you. Some are flickering with age. Some are being born. Some have already gone out, but their light is still on the way. The stars you'll never see are still there, still moving, still burning, and you are part of that light, even if you can't see it. Right now, as you lie still, the earth is turning beneath you. You don't feel it, of course. The rotation is smooth, continuous, and constant, like being carried on a conveyor belt that wraps around the planet. But there's more. The earth itself is moving too. It's circling the sun at nearly 30 kilometers per second. And that sun, it isn't fixed. It's not anchored in place. It's in motion as well, spiraling slowly through the galaxy like a glowing ember carried on a breeze, drifting not aimlessly, but along a vast, invisible path carved by gravity and time. Our sun is orbiting the center of the Milky Way, dragged by the mass of billions of stars and the pull of dark matter. This path is not tight like the Earth's orbit, not neat or quick. It is slow and wide, taking roughly 225 to 250 million years to complete a single circuit. That loop is called a galactic year. It is so immense, so drawn out, that entire eras rise and vanish before it is done. When the sun last passed through this same part of the galaxy, the continents on Earth were fused together into the supercontinent Pangaea. Dinosaurs did not yet exist. The air was different. The oceans younger. Everything we call recent, everything recorded in human history, has happened within the tiniest sliver of one galactic year. Since the sun was born, about 4.6 billion years ago, it has only made between 20 and 22 full laps around the galaxy. That's it. In all its long burning life, it has traveled this spiral path just a few dozen times. It means we are young, cosmically speaking. Not in how many years we've counted, but in how little ground we've covered. We have not been here long enough to see the shape of things repeat. The orbit itself is not a perfect circle. It is more like an ellipse, tilted slightly with respect to the galactic plane. As the sun makes its way around the Milky Way, it also bobs gently up and down, weaving through the disk like a cork floating along a rippling river. Some researchers believe this slow vertical motion may even influence extinction cycles on Earth as we pass through regions with higher concentrations of dust, gas, or cosmic radiation. The path we follow is not smooth. It is dynamic, woven with consequences we are only beginning to understand. Despite the sun's seemingly steady light, it is a traveler. Our entire solar system is moving at staggering speed, over 828,000 kilometers per hour, around the galactic center. That's roughly 230 kilometers every second. And yet the stars do not blur. The constellations do not smear across the sky. Everything feels still because we are moving with it. All of us. Every atom, every breath, every heartbeat is riding this silent arc together. The center we orbit is hidden from us, buried beneath thick clouds of dust and gas, deep in the direction of the constellation Sagittarius. But we know what lies there. At the very heart of the Milky Way is a supermassive black hole, more than 4 million times the mass of the sun. It anchors the galaxy, not like a hook, but like a whirlpool. shaping the movement of stars across hundreds of thousands of light years. Our sun is not drawn toward it directly, not spiraling in like water down a drain, but locked in a sweeping, stable orbit, part of the galaxy's greater swirl. Over time, everything changes. The arms of the Milky Way twist and shift. Stars are born and die. Clouds of gas collapse and disappear. But the sun continues its patient journey, circling without pause, a small glowing thread in a much larger weave. The solar system carries its planets like a lantern carries shadows, each one held in place by gravity, each one moving together through the dark. From our perspective on Earth, this motion is almost impossible to feel. The stars we see tonight seem like permanent fixtures. Polaris remains at the north. Orion hunts the winter sky. The same constellations return with the seasons, guiding sailors, storytellers, and dreamers alike. But even these familiar patterns are temporary. As the sun drifts through the galaxy, the positions of nearby stars shift subtly, their distances changing, their arrangements evolving. Thousands of years from now, the sky will look different. The Big Dipper will melt. Orion will twist. The map of stars we know is only a snapshot, a moment caught in the sun's long spiral. And still, we imagine the cosmos as still, as frozen. But the Milky Way is not a fixed sculpture. It is alive with motion. Stars race inward and outward. Some loop in elongated orbits. Others fall from above the disk like rain. Our sun is one among billions, each on its own path, each playing its part in the galaxy's rhythm. It's not a synchronized dance, but a drifting current, a galactic tide. And we are carried within it, silently, ceaselessly, through a night far vaster than we can see. There's a kind of comfort in that, knowing that everything is in motion, that change is not something to fear, but something that defines our place, even the most stable things. Our sun, our orbit, the rising of the moon, are part of something larger that never stands still. We move forward, together, not always knowing where the path leads, but trusting the turn. So as you rest tonight, your body still and your breath slow, the earth is turning, the sun is circling, the galaxy is unfolding. You are part of a motion older than memory and longer than time, and somewhere ahead, billions of years from now, the sun will complete another lap. The stars will be different. The sky will be strange. But the spiral will continue. Quiet, steady, eternal. If you could float above the Milky Way and watch it not just with your eyes, but with senses tuned to temperature and motion, you'd see that it breathes. Not like lungs exactly, but like a great organism exhaling and inhaling through the rise and fall of energy and matter. The galaxy is not static. It does not simply spin, it pulses. It moves with a rhythm so slow you would never feel it, so vast you would never see it, and yet it is there, steady, cyclical, alive in its own way. Between the thin disk of stars where we live and the hazy halo that surrounds the galaxy like a luminous veil, something remarkable happens. Clouds of gas are drawn upward from the disk, rising like vapor off a hot road. They're not random. They're fountains, arcs, arising in loops and ribbons. They stretch from the starry plane into the galactic halo, where they cool and fall again, feeding the cycle of star birth below. These flows are sometimes gentle, but often violent, the result of fierce processes deep in the heart of star-forming regions. A single supernova can send shock waves rippling through space, stirring the gas and dust around it, sweeping it into vast shells that rise from the disk like smoke from a fire. But when stars form in great clusters, in dense knots of gas, where dozens or hundreds ignite together, the effects are magnified. These clusters create what are called starbursts, intense periods of stellar birth that flood the surrounding space with ultraviolet light and fierce winds. The heat builds, the energy expands, and then, as if the galaxy is venting its fever, Enormous chimneys open through the disk, releasing streams of superheated gas into the halo above. These aren't gentle sighs. They are eruptions, invisible to the eye, but stretching thousands of light years high. Some move so fast they reach escape velocity and never return. Others cool and fall back, bringing with them traces of the stars they left behind. These winds and fountains don't just carry heat, they carry metals too. In astronomy, metals means any element heavier than hydrogen or helium, the building blocks of planets, moons, oceans, and living things. These are the ashes of stars, forged in their cores or during their deaths, and blown outward into the galaxy with each breath. Through these winds, the galaxy seeds itself, spreading elements far beyond their birthplaces, enriching clouds that have yet to collapse, preparing the soil for future stars and their worlds. This isn't a uniform process. The Milky Way breathes unevenly. Some regions are quiet, drifting through long seasons of calm. Others flare with activity, driven by clusters of young, hot stars or by the tidal pull of satellite galaxies. But over time, the pattern holds. Inflows, outflows, cooling, heating, collapse, expansion. A cycle not of lungs but of feedback. A balance between creation and dispersal, between the forces that gather matter and those that push it away. The galactic halo, once thought to be an empty shell, is now understood to be a vast reservoir. It holds not just old stars and globular clusters, but gas. Lots of it. More gas, in fact, than we once thought existed. And this halo gas isn't still. It churns. It mixes. It is stirred by the very breath of the galaxy, by the winds and fountains that rise from below. The disk and the halo are not separate. They are connected, like deep ocean currents, linking surface to seafloor, moving mass and memory between layers. The galaxy's heartbeat is not something we can hear. It doesn't pulse in seconds or minutes, but in millions of years. A cycle of energy flowing out, cooling, and returning. These timescales are so long that even civilizations, with their languages, their histories, their hopes, flicker and vanish in the span of a single rise and fall. And yet the breath continues. It is the background rhythm against which everything else unfolds. Without it, the galaxy would stagnate. It would grow cold, uneven, starved, but with it, material is recycled, stirred, and renewed. Even here, near our quiet sun, we are part of that movement. The gas from which our solar system formed was enriched by countless earlier generations of stars. Their winds passed through the disk, into the halo, and back again, depositing carbon, nitrogen, oxygen, the very elements in your blood and bones. You are, quite literally, made from the breath of the galaxy. When we look at galaxies far away, we can sometimes see these winds more clearly. In starburst galaxies, the chimneys of gas shine in infrared and X-ray, towering above the disk like ghostly flames. We see what's happening there and understand that something similar is happening here, though more subtly. The Milky Way, with its billions of stars and its delicate spirals, is also alive with these invisible movements, these thermal sighs and gravitational tugs. From Earth, these processes remain unseen. The stars do not flicker in response to the galaxy's breath. The sky does not pulse. The fountains do not glow. But with the right instruments, with radio telescopes, X-ray detectors, ultraviolet sensors, we can watch the motion. We can trace the pathways of gas. We can follow the currents of matter rising and falling, heating and cooling, being born and reborn. This breathing is not random. It is not noise. It is memory made physical. Every outflow carries the history of the stars that shaped it. Every returning stream carries the promise of what might come next. The galaxy is not only a structure, it is a story told in the motion of gas and the silence between stars. So tonight, as you lie in stillness, Remember that even silence has rhythm. Even the coldest void is full of motion. The Milky Way is breathing. Right now, slowly, steadily, across spans of time too vast to imagine. You don't need to hear it to believe it. You are a part of it. You always have been. If you've ever seen a photograph of the Milky Way or any other spiral galaxy, you've likely imagined those graceful arms as static, majestic tendrils of stars wrapped in symmetrical curls, frozen in elegant motion across eons. It's easy to picture them that way, fixed, permanent, as though they are etched into the galaxy, like grooves in a record, guiding the stars along invisible tracks. But that's not how it works. The arms aren't made of the same stars over time. They're not objects. They're patterns. Think of a traffic jam on a highway. Not the cars themselves, but the way they bunch and spread. The jam is a shape made by movement, not by permanence. The cars enter and leave the congestion, but the traffic knot seems to stay in place. That's how spiral arms behave. They're not structures built from specific stars, locked into place forever. They're density waves, compressions in the galactic disk, where stars and gas get bunched together for a time before moving on. The wave moves more slowly than the stars orbiting the center, so stars drift into the arm from behind, linger, then slide forward and out again. This means that the beautiful curves we see are illusions of persistence. The arms are not the same from 1 million years to the next. They shift and ripple, stirred by the gravitational interplay between stars, gas, and dark matter. New stars are born in the denser regions of these waves, lighting up the arms in blue and white, while older stars drift into the quieter, redder spaces between. What we call spiral arms are not lines but rivers, flowing, forming, fading, held together not by solid mass, but by gravitational choreography. Even the number of arms isn't always clear. Some galaxies have 2, others 4. Some have many, faint and loose, like threads unraveling in space. Our own Milky Way likely has 4 major arms, though we can't see them fully from within. We see hints of them, concentrations of stars, clouds of dust, the glowing path of hydrogen, but we cannot step back and look at the whole spiral from above. We reconstruct the shape through measurement, mapping, inference. It's like trying to understand a forest while standing in the middle of it, watching only a few trees at a time. And here we are, inside one of those arms. Our solar system is currently swimming through a minor spur, not one of the main arms, but a smaller offshoot known as the Orion arm or Orion Spur. It's tucked between the larger Sagittarius and Perseus arms. This region is relatively calm, a quieter stretch of galactic real estate, which may be part of the reason life here has had time to evolve without being constantly disturbed by too many nearby supernova or gravitational disruptions. But we are moving, always. The sun is not fixed in this position. It drifts along with the stellar flow, orbiting the galaxy's center and crossing through different parts of the disk over time. Every few 100 million years, the sun and its planets pass through one of the larger spiral arms. These passages may bring changes, more nearby stars, more radiation, more gravitational interactions. Some scientists have speculated that these crossings could even influence extinction events on Earth, though the evidence is still debated. What's clear is that our environment is not constant. We are riding a wave, not resting in place. The stars around us are doing the same. They enter the denser regions, then exit, tracing paths governed by gravity and momentum. The spiral pattern, meanwhile, holds. Not rigidly, not precisely, but with a kind of slow grace, a long-lasting ripple in the fabric of the disk. If we could speed up time, compress millions of years into a few seconds, we'd see the galaxy ripple and pulse, the arms flashing bright as stars ignite, then dimming as they drift away. There's something humbling in this realization, that the spiral arms, as grand and defined as they appear, are not made of anything fixed, that they are shapes drawn by movement, not mass. that even something as vast and seemingly eternal as the galaxy's structure is built on change. It reminds us that patterns can persist even when their pieces do not. That identity doesn't always come from what something is, but from how it flows. When you look up at the night sky and see the band of the Milky Way stretched faintly across the darkness, you're looking through one of these spiral patterns from the inside. The stars you see belong to different neighborhoods, different times, different flows. Some are racing ahead of the density wave. Some are just entering it. Some, like our sun, are gliding quietly through a side street, watching the bright curls from a comfortable distance. And still, we're part of it. Part of the movement, the rhythm, the shape. Our solar system drifts, not randomly, but as part of this great rotating tapestry. And as we orbit the center of the galaxy, we pass through regions lit by newborn stars, veiled by dust, shaped by waves we cannot feel. We are not passengers on a still ship. We are fish in a cosmic current, swimming through spirals of light and gravity. The arms of the galaxy are not what we once thought they were, but that makes them no less beautiful. If anything, it deepens the wonder, because now we know they are not rigid tracks, but living patterns. Not frozen structures, but flowing echoes of motion, and we are caught in them, always moving, always changing, part of the dance we only barely understand. Galaxies are not gentle things. From a distance, they appear serene, swirling disks of starlight suspended in the darkness, arms spiraling gracefully outward, glowing softly like lanterns in the night. But up close, their histories are more violent. The Milky Way, for all its quiet beauty, was built through collision. It did not emerge fully formed or evolve in isolation. It grew by devouring others. Long ago, before Earth existed, before our sun had even ignited, the Milky Way collided with a smaller galaxy, now called Gaia Enceladus. This was no minor brush. It was a transformative event, a slow-motion merger that lasted hundreds of millions of years. The stars of Gaia Enceladus were absorbed into the Milky Way's growing mass. Their orbits disrupted, their momentum redistributed. Some of the oldest stars in the sky still carry the kinematic fingerprint of that collision. They move differently, tilted against the plane of the disk, looping in elongated, chaotic paths. They are ghosts of another time, foreign bodies woven into our own. This collision reshaped everything. It thickened the disk, stirred the halo, and infused the young Milky Way with new energy and material. Some scientists believe it triggered fresh waves of star formation, igniting gas that had cooled into clouds, giving birth to new generations of stars, new clusters, new possibilities. The galaxy did not simply survive the impact. It grew stronger because of it. And Gaia Enceladus was not alone. Our galaxy has cannibalized many companions. Some were torn apart long ago, their remnants fully blended into the stellar population. Others are still being digested. One of the most well-known is the Sagittarius dwarf spheroidal galaxy, a small satellite galaxy that has been orbiting the Milky Way in a decaying path for billions of years. With each pass through the Milky Way's disk, it loses more of itself. Stars stripped away by tidal forces, streams pulled from its flanks like threads unraveling from cloth. It is a galaxy being unmade, devoured slowly, pulled apart strand by strand. We can see the remnants of these feasts. They stretch across the sky in arcs and rivers of stars, faint and vast and ancient. These stellar streams are the scars of collision, remnants of galaxies that no longer exist as independent entities. The stars within them still move together, still remember where they came from, even if the galaxies that birthed them are now gone. Some wrap around the Milky Way like ribbons. Others fall in like rain. They are maps of forgotten structures, their trajectories revealing both where they came from and how the Milky Way has grown. These mergers are not rare. They are part of how galaxies evolve. Gravity draws them together, and when they meet, They do not simply bounce off each other. They merge. They blend. In the vast, empty spaces between stars, actual collisions are rare, but the gravitational interactions are profound. Orbits shift, shapes distort, streams form. Sometimes, entire structures like globular clusters are captured intact, hanging on like stowaways in the aftermath. Even now, as you listen, our galaxy is surrounded by smaller companions, the large and small Magellanic clouds among them, circling like moths near a flame. Simulations suggest they may one day be absorbed too, adding their stars to our own, contributing to the endless layering of motion and memory. The galaxy you live in is not finished. It is still assembling itself. It's easy to imagine galaxies as islands, separate and self-contained, but that's not the reality. They are social, dynamic, and hungry. The universe is built on interaction, on blending, on the exchange of matter and motion. Every star you see may carry echoes of this history, born in a cloud stirred by an ancient merger, enriched by the metals of another galaxy's dead. Even the sun, quiet and familiar, is a child of this cosmic inheritance. Our galaxy is not uniform. It is textured with difference, with motion, with the lingering presence of long-ago collisions. Some stars orbit in the flattened disk, others drift in the halo, looping slowly in eccentric paths. Some are part of tidal streams, still tracing the outline of what they once were. If you could watch the galaxy from above, not just for one night, but for billions of years, you'd see it shift and shimmer with motion. Arms curling tighter, streams folding inward, new material falling in from every direction. This is how the Milky Way became what it is, through absorption, through chaos, through grace born of disorder. And though these mergers span timescales longer than any one life, their traces remain, etched into the motions of stars, into the structure of the halo, into the very chemistry of the stars that make up the night. So when you look up and see the stars, know that they are not just distant points of light. They are the afterglow of collision, the evidence of galaxies that met and merged, that broke and blended, that gave themselves to something larger. The Milky Way is not one thing. It is many things, layered and fused, still reshaping itself in slow, deliberate motion. Even silence, it turns out, has an origin in sound, and even the stillness of the night sky carries the memory of impact. At the very center of the Milky Way, hidden behind clouds of dust and veils of light, lies something silent and immense. It does not shine. It does not speak, but it holds the entire galaxy in its grip. This is Sagittarius A*, the supermassive black hole at our core. More than 4 million times the mass of our sun, it rests at the crossroads of gravity and mystery, quietly anchoring the spiraled sweep of hundreds of billions of stars. You can't see it with your eyes. You wouldn't feel it if you were drifting nearby. And yet, it shapes the orbit of our galaxy like a stone shapes the course of a river. For decades, astronomers suspected something unusual was there. In the very center of the Milky Way, stars moved strangely. They swung around a point that emitted no light, accelerating to speeds that defied expectation. Some traveled faster than any object we've ever observed outside of particle colliders, looping in tight curves, their paths bent sharply by something invisible. Over time, with years of observation and the careful tracing of stellar motion, it became clear. These stars were not orbiting another star or cluster of stars. They were circling a mass that emitted no visible radiation at all. A black hole. Not a small one, born from the death of a massive star, but a supermassive one, millions of times heavier than our sun, and yet it fit into a space no larger than the orbit of Mercury. The math made no other sense. The lightless center, the wild orbits, the gravitational pull. It all pointed to a single, silent truth. Something impossibly dense sat at the heart of the Milky Way. Sagittarius A times, does not behave like the black holes in science fiction. It does not stalk the galaxy, devouring stars at random. It is quiet, dormant, mostly. Every so often, a bit of gas or a wandering fragment of dust spirals too close and falls past the event horizon. In those moments, the black hole flares briefly as matter compresses and heats on the way in. But these events are rare. For the most part, Sagittarius A times sits still, a great gravitational well in the dark, watching everything spin. We've never seen it directly, not in the way we see stars or planets or even nebulae, but we've seen its effect. And more recently, with the Event Horizon Telescope, a global network of synchronized radio dishes, we've seen something else. Its shadow, not the black hole itself, which can never be seen, but the silhouette it casts against a glowing halo of superheated matter swirling near its edge, a ring of light bent by gravity, a void where no light escapes, a silence made visible. It's strange, the way the universe hides its most massive things. Stars burn brightly for billions of years and then vanish in collapse, leaving behind an object so dense, so complete in its gravity, that not even light can leave. There is a kind of finality to a black hole, but also a kind of beginning, because everything orbits something, everything responds to a center, and for us, for this galaxy, that center is a darkness deeper than anything we can imagine. The stars that orbit close to Sagittarius A times do so with breathtaking speed. Some complete their journeys in just a few years, tracing ellipses so tight they pass within mere light hours of the black hole's edge. They whip around and sling back out again, their momentum borrowed from the immense gravity that holds them close. These stars are like dancers moving too fast for the music, their paths a choreography that would tear most objects apart. But they endure, held together by their own mass, and the careful balance of motion and pull. They've given us insight. By measuring their movements, year after year, with precision, we've confirmed Einstein's predictions about how space bends and time stretches near such massive bodies. We've tested the limits of our physics against the motions of stars that no human eye could ever see unaided. And we've watched, in real time, as a galaxy responds to the darkness at its heart. Still, questions remain. Why is it so quiet? Why, when other galaxies blaze with the furious energy of active black holes, does ours sit so still? Is it sleeping? Waiting? Was there a time when it consumed more, when jets of energy streamed from its poles and radiation lit the galactic center like a beacon? The evidence suggests it may have been more active in the past, leaving behind echoes in X-rays and strange chemical fingerprints in nearby gas. But now, it rests. That stillness is not empty. It is full of weight. Sagittarius A times holds the center of the Milky Way together. It shapes the orbits of stars thousands of light years away. It creates a gravitational landscape in which the spiral arms form and move. Without it, the galaxy would unravel, the disk would drift, the stars would scatter into something unrecognizable. It doesn't need to shine. Its presence is enough. And there's something quietly profound about that at the center of everything, at the heart of all this light, all this motion, all this structure, there is a void, a darkness we cannot see into, a silence that holds the sky in place. So as you lie in your bed, wrapped in the hush of night, know that at the core of the Milky Way, across thousands of light years, a black hole sits in the dark, not menacing, not wild, but still, steady, waiting, holding. The stars know it's there, the galaxy knows, and now, so do you. Out in the spiral arms of the Milky Way, in pockets where starlight dims and shadows stretch wide, there are clouds so vast and cold they seem like nothing at all. You might pass them by if you didn't know better, mistaking them for blank space, a void between constellations. But these clouds are not empty. They are waiting. Within them, Something ancient and ongoing stirs, something so gentle and slow that it escapes the notice of time. These are the stellar nurseries, and from them stars are born. It begins in darkness, the kind of darkness not caused by absence but by density. Molecular clouds, vast regions of hydrogen and dust, drift through the galaxy in quiet obscurity. Some stretch for hundreds of light years, thick enough to blot out the stars behind them entirely. They are among the coldest places in the universe, just a few degrees above absolute zero, their particles moving sluggishly, conserving energy, holding still. In this stillness, gravity finds its foothold. Slight differences in density pull gas inward, creating knots, ripples, instabilities that grow ever so slightly stronger with time. As more mass falls in, the pull strengthens. Regions begin to collapse under their own weight, forming dense cores where matter compresses further, heating slowly as the atoms are squeezed tighter. It takes millions of years. Nothing about this process is fast or loud, but eventually, deep inside those cores, the pressure and heat become high enough to ignite fusion, the process that powers every star you've ever seen. In that moment, the newborn star begins to shine. But it doesn't emerge into the world alone. It is surrounded by the remains of the cloud that birthed it, gas and dust that absorb the light and scatter it, making the region glow in strange ethereal hues. The ultraviolet radiation from these infant stars ionizes the gas around them, lighting up the clouds in soft blues and pinks, colors we can see in the nebulae captured by telescopes. These stellar nurseries are not quiet places. Though they began in silence, they soon become radiant and alive. The Orion Nebula is one such place, visible even to the naked eye as a faint blur in the sword of Orion's belt. It's a real nursery, less than 1,500 light-years away, teeming with young stars and proto-systems, swirls of gas and dust where planets may someday form. It's only one of thousands scattered across the Milky Way, each telling a story of slow creation, of energy gathering in darkness until it cannot help but burn. These regions shape the spiral arms themselves. The arms are not rigid structures. They are patterns in motion, waves of density that compress gas as they pass. Where the wave moves through, it pushes gas clouds together, increasing the chance of star formation. That's why the arms appear so bright in ultraviolet and visible light. They are lit from within by the stars they helped create. As new stars ignite, they mark the wave's passage like glowing embers flaring in a breeze. But not all stars survive. In crowded nurseries, competition is fierce. Some proto-stars pull in more mass and grow large, burning hot and fast. Others are stripped of material before they ever get the chance. Some form in clusters, bound together by their mutual gravity, while others drift off alone. The largest stars live only a few million years, brief, furious lives that end in supernovae, scattering the elements forged in their cores back into the interstellar medium. The clouds they came from are shaped and stirred by these explosions, seeded with heavier elements for the next generation of stars. So, the cycle continues. Gas forms clouds, clouds form stars, stars explode and return their elements to space. And from that enriched material, new clouds form again, carrying the chemical fingerprints of all that came before. You are made of that same material. Carbon, oxygen, iron, all born in stars that once lit the arms of the Milky Way long before Earth ever coalesced. The process never really stops. Even now, in regions far from the reach of our eyes, stars are forming, entire systems, perhaps with planets, perhaps with oceans, perhaps with watchers of their own, are taking shape in the cold folds of dust between the stars. It's happening while you sleep, while you breathe, while the earth rotates quietly beneath the sky. And though we may never visit those nurseries, never stand beneath the newborn suns, we carry their light in our bones. Every star you see was born from a cloud like this. Every night sky is a window into the quiet labor of creation, stretched across distances too vast for our feet, but not for our minds. Stellar nurseries remind us that beauty can begin in darkness, that silence can give rise to radiance, that even the most unassuming spaces may hold within them the seeds of light. And somewhere, out there, another sun is being born. High above the flat disk of the Milky Way, far from the bright churn of its spiral arms, there are clusters of stars so old they've forgotten the world we know. They orbit in the galaxy's halo, not bound to its plane but suspended around it, circling like distant memories. These are the globular clusters, dense, spherical gatherings of ancient stars, and within them lie some of the oldest things the universe has ever made. Some of these stars are nearly as old as the cosmos itself. Born more than 13 billion years ago, they blazed into life when the universe was still young, just a few 100 million years past the Big Bang. At that time, galaxies were only beginning to form, still gathering shape from the cooling remnants of creation. These stars, low in metals and high in endurance, lit up the dark long before the Milky Way had settled into its familiar spiral form. They are older than the arms, older than the sun, older than the idea of Earth. They burn with a steady, amber glow, their surfaces untouched by the heavy elements that fill younger stars. These are metal-poor stars, forged in a universe that had not yet been enriched by supernovae. In astronomy, metals means anything heavier than helium. Oxygen, carbon, iron, all the ingredients for planets and life. These ancient stars lack them. They were born before the universe knew how to make them, before the stars themselves had lived and died enough times to build the heavier elements from fusion. They are simple, pristine, primordial, and yet they still shine. Globular clusters contain tens of thousands, sometimes hundreds of thousands, of stars packed into spheres only a few dozen light-years wide. Imagine that density, a sky filled not with pinpricks of light, but blazing suns in every direction. These are not places where night falls gently. They are glowing hives, radiant with the warmth of old fire. Most of their stars are red giants and yellow dwarfs, aged and slow burning, still holding their fusion at bay after all this time. The Milky Way is wrapped in these clusters like a cloak. More than 150 of them orbit the galaxy in long, elliptical paths, arcing above and below the disk. Some pass near, some wander far, but all of them remain tethered by the galaxy's gravity, companions to its rotation but not truly part of its fabric. They drift like satellites, loyal to an origin that precedes what we call home. When astronomers study these clusters, they are not just looking at stars, they are looking at time. Every spectrum, every pulse, every orbit is a data point in the history of the cosmos. Some of the oldest known stars, such as those in the cluster M92 or in the ancient region of the Bulge, are relics of the early universe. Their light carries the signature of a different era, when the cosmic rules had barely begun to settle, and they haven't faded. Even after billions of years, they still glow steadily, radiating warmth across space like embers from the first fire. You could argue they are fossils, but not of bone or stone. Fossils of light. Fossils that illuminate rather than petrify. They've outlived generations of stars that came and went, outshone entire clusters that burned bright and collapsed. Their patience is extraordinary. In a universe obsessed with energy and speed, they have chosen persistence. It's strange to think that something can outlive its context. These stars were born before the Milky Way took its modern shape, and yet here they are, orbiting its center like old sentinels. They watched as the spiral arms coalesced, as mergers reshaped the galaxy's core, as new stars formed in luminous nurseries. They've circled through it all, untouched by the chaos beneath them. Time passes differently up there, in the halo, where fewer collisions and lower densities offer a kind of isolation, a cosmic quiet that favors longevity. Their orbits are wide, often taking hundreds of millions of years to complete. Some move in retrograde, against the general rotation of the galaxy, a clue that they may have come from somewhere else entirely. Captured remnants of other smaller galaxies the Milky Way consumed long ago. Others show signs of internal evolution, stars migrating within the cluster, shifting slowly as gravitational tides pass through. But the core remains, the shape holds, the light continues, and within that light, we see not just the past, but the future. These stars remind us that survival is possible. That brilliance doesn't need to be fast or violent. That to burn slowly, with quiet strength, can be a triumph of its own. They offer a counterpoint to the supernovae and quasars, to the dramatic deaths and explosive births. They are a whisper beneath the roar, a steady rhythm beneath the spectacle. If you ever find yourself staring at the sky, wondering how something so vast can hold together, think of these ancient stars. Think of the way they've endured, circling in silence, their orbits etched deep into the galaxy's skin. Think of the first light they emitted, long before our sun was born, still making its way through space, still arriving, because even the oldest stars are still speaking, still shining, still there. The Milky Way is not what it seems. When you look up on a clear night and see the faint band of starlight stretched across the sky, what you're seeing is only the surface. A shimmering skin stretched over something much larger, much stranger, and profoundly invisible. The stars are real, the gas and dust, the spiral arms and glowing nebulae, all of it present and beautiful. But they are only a fraction of the truth. Most of what makes our galaxy whole is something we cannot see at all. It casts no light, no shadow. It reveals itself not through wise shape or color, but through the quiet force of gravity. It's called dark matter. For decades, astronomers have measured the movements of stars, the orbits of gas clouds, the rotation of galaxies. And again, the numbers do not match what we see. The outer stars in the Milky Way rotate far too fast. So fast that if only the visible matter were pulling on them, they would spin away into space like droplets from a turning wheel. The galaxy would unravel, losing its structure, its arms, its cohesion. But it doesn't. It holds. It turns with grace and balance. It survives. Something unseen is holding it together. That something is dark matter. We don't know exactly what it is. We've never captured a particle of it in a lab, never observed it directly through a telescope, but we can feel it everywhere in the galaxy, in the curvature of orbits and the velocity of stars. It acts like scaffolding, an immense framework that binds the galaxy in place. Without it, the Milky Way wouldn't exist in the form we know. It wouldn't be a disk of stars. It would be chaos. The strange thing is, dark matter doesn't clump like normal matter. It doesn't fall into stars or gather into planets. It passes through ordinary atoms without interacting. It doesn't emit radiation or absorb it. It doesn't shine, doesn't glow, doesn't burn. And yet, it surrounds everything, envelops the galaxy in a vast, invisible halo that stretches far beyond the furthest stars. This halo is like a ghost shell, enormous, weighty, and present, even if you can't see it. Imagine the Milky Way as a glowing city seen from space. The lights mark the places where activity happens, where stars gather, where life might exist. But surrounding that city is a dark, invisible infrastructure. Roads, pipes, cables, power lines, unseen but necessary. Without them, the lights wouldn't work, the buildings wouldn't stand, the city wouldn't function. Dark matter is that hidden structure on a cosmic scale. It holds the lights in place, and the more we study it, the more it challenges us. Every test, every simulation, every line of gravitational evidence points toward its existence, and yet it refuses to let us near. It's like a whisper behind a door that won't open. We map it by its absence, like tracking the wind through the movement of leaves. We know it's there because the galaxy would fall apart without it. It's estimated that more than 80% of the Milky Way's total mass is made of dark matter. That means everything you can see. The stars, the planets, the dust, the glowing arms, the black holes and gas clouds. All of it combined is only a small sliver of what's truly there. We are drifting through something immeasurable and silent. Every second of your life, you are moving through dark matter. It doesn't touch you. It doesn't slow you down, but it surrounds you just the same. There's a strange comfort in that, isn't there? That the most important things might not be the loudest or the brightest. That something unseen can still hold everything together. That, even in the apparent emptiness, there is structure. Not everything needs to be illuminated to be real. Scientists have tried for decades to understand what dark matter is made of. Theories range from exotic particles to undiscovered forces, from shadow matter to alternate dimensions intersecting our own. Detectors buried deep underground wait for a flash, a signal, a sign. So far, nothing has come. The silence continues. But in that silence, galaxies still spin. The structure of the universe remains. You don't need to understand it to feel its pull. The Earth circles the sun, which circles the galaxy, which in turn is dancing within the grip of this invisible halo, a ballet of gravity, a quiet tether. The stars themselves respond to it, and through them, we do too. Dark matter is not just a mystery of physics. It's a philosophical presence, a reminder of how little we truly see, of how much can lie beyond perception, guiding everything without ever showing its face. The galaxy is not just a place of light. It is built, cradled, and carried by a darkness we are only beginning to notice. So when you look at the Milky Way next time, when you trace its arc across the night sky, or glimpse its curve from some mountaintop or distant desert, remember that you're seeing only the edge of something far greater. The glow is beautiful, yes, but the silence beneath it is just as essential. The stars are the song, but dark matter is the breath that carries it. We live in a galaxy shaped by shadows, shadows that do not fall, but lift, shadows that do not obscure, but support. And in that unseen lattice, the universe takes form, quietly, invisibly, always. If you were to step far enough away from the Milky Way, out beyond its halo, past the veil of dark matter, into a place so distant that the entire galaxy could be held in your field of view, you might expect to see a neat, symmetrical spiral, like a pinwheel pressed against the black. But that's not what you'd find. The Milky Way is not a perfect disk. It is rippled, warped, bent at the edges like a slow-motion wave caught in mid-rise, as though the galaxy is breathing or shifting its weight while it spins through space. The arms don't sit evenly in a plane. They curve upward in one direction and dip downward in another, like a massive, luminous leaf caught in a gentle wind. This warp is not a flaw. It is a consequence of motion, of interaction, of gravity doing what gravity always does, pulling things toward other things. The Milky Way is not alone. It is surrounded by smaller satellite galaxies, fragments of other systems, clusters of stars, and streams of matter left behind from ancient collisions. Some of these companions are close enough to influence us. Their mass tugs on the edges of the galactic disk, not in a single jerk, but with a slow, constant rhythm, like fingers pressing gently on the rim of a drum. And so, the disk bends. It doesn't happen quickly. It's not the kind of wobble you'd notice in a moment or a day, or even a lifetime. But over millions of years, the distortion becomes clear. The outer edges of the galaxy, particularly in the hydrogen gas that extends far beyond the visible stars, lift above the central plane and then fall below it, tracing a subtle shape through space. It's not just a bend, it's a pattern, a rhythm, a galactic tide. We ride that wave without ever feeling it. The solar system, nestled in one of the galaxy's minor arms, is moving through this warped disk as it orbits the core. The stars around us are part of the same swell, rising and falling in unison over incomprehensible timescales. We're not on a flat racetrack. We're on a living, undulating ribbon of stars, rippling with the echoes of cosmic encounters. The source of this warping isn't fully understood, but we have suspects: the large and small Magellanic Clouds, two of our closest galactic neighbors, are prime candidates. These irregular dwarf galaxies orbit the Milky Way and appear to be interacting with our dark matter halo. Their gravitational presence, amplified perhaps by the invisible structure that surrounds us, may be enough to twist the edges of our disk. It's not a collision. It's more like a slow gravitational conversation, long, drawn out, and impossible to ignore. But even that might not be the full story. Some scientists suspect that the warp may be a lingering effect from a past merger. Another galaxy, now long since absorbed, that passed through us and left behind a lasting tremor. Like a boat gliding through water, the wake it created still reverberates in the stars. There's also a wobble, an oscillation in the vertical motion of stars that seems to ripple through the disk like a shiver. Some stars rise above the galactic plane and then fall below it in a pattern that suggests the whole disk is gently vibrating. These waves may have been triggered by satellite galaxies plunging through the Milky Way's midsection, sending ripples outward like a pebble dropped in a pond. The galaxy absorbs these impacts, but it does not remain still. It responds slowly and elegantly. The warp and wobble are reminders that the Milky Way is not fixed in place. It is not a finished structure hanging in the void. It is still forming, still flexing, still reacting to the environment around it. It breathes in gravitational terms, stretching here, sagging there, shifting like a living organism under the pressure of its surroundings. From Earth, it's easy to imagine space as static. The stars seem fixed. The constellations don't change across a human lifetime. But scale deceives us. Over tens of millions of years, even the sturdiest shapes are fluid. Mountains erode, oceans shift, galaxies bend. Time reveals the dance we cannot see. So here we are, riding a wave of stars. Every night, when you look up at the hazy arc of the Milky Way cutting across the sky, you're seeing a moment in that motion. A frozen frame in a film that plays too slowly for our senses. But it's there. The entire galaxy is flexing, its arms rising and dipping through space, pulled by unseen hands, stirred by ancient memory. We think of stars as constants, fixed points in the sky, but they are part of something much more dynamic. They're part of a river that moves even as it glows, a spiral that bends like wind-blown fabric, a disk that wobbles like a coin coming to rest. This warping doesn't make the Milky Way broken, it makes it alive. In the vast, humming machinery of the Milky Way, most stars move with quiet loyalty. They trace their orbits around the galactic center in graceful, predictable loops, bound by gravity and time. The spiral arms sweep them along like dancers in a cosmic waltz, always returning, always part of the whole. But not all stars stay tethered. Some break, free. Not in defiance, but because the galaxy itself sometimes lets go, or throws. There are stars, lonely, brilliant wanderers, that have been flung from the Milky Way with such staggering speed that they will never come back. They are called hypervelocity stars, and they do not orbit anything. They fly, straight into the void between galaxies, into the dark between lights, into a place where starlight fades into cold, and where they will shine alone for the rest of their lives. These stars don't drift gently out of the Milky Way's edge. They are launched, hurled at speeds exceeding 2 million kilometers per hour, fast enough to escape the gravitational grip of an entire galaxy. Imagine the violence required to do that, to send a sun-sized object into permanent exile. These events are rare, but they happen, when they do, they reshape the boundaries of what stars can be. One of the most common culprits is the supermassive black hole at the heart of the Milky Way, Sagittarius A*. Its gravity is so immense that anything that comes too close is either devoured or distorted. When a binary star system, a pair of stars orbiting each other, wanders near the black hole, the tidal forces can tear them apart. One star may be captured, pulled into orbit, or consumed entirely. The other is flung outward with a slingshot of energy so intense it leaves the galaxy behind. What begins as companionship ends in separation more final than death, and once they go, they do not return. These stars travel into intergalactic space, where the distances between galaxies are measured in millions of light years, and where the night sky is not a crowded canvas but a sparse, echoing silence. They carry with them the signatures of their origin, chemical fingerprints, spectral clues, but nothing else. No planets, no neighbors, no system to call home. Just motion, just momentum. Most hypervelocity stars are blue, hot, young, and massive. Their short lifespans mean they may burn out before reaching another galaxy. They will live their entire lives in exile, racing toward nowhere, watched by no one. Their story is one of motion without destination, of speed without return. A star like that does not settle. It blazes, and then it goes dark, still moving, still untouchable, even after its light has faded. There are other ways stars become rogues. Some are ejected not by black holes, but by the collapse of stellar clusters. When massive stars go supernova in dense regions, the shock waves can destabilize nearby stars, ejecting them like marbles from a shaken bowl. These stars don't always reach galactic escape velocity, but they do become wanderers, no longer anchored to any cluster or arm. They drift within the galaxy, strange and solitary, unclaimed by any structure. Others are remnants of galactic mergers, stragglers from galaxies the Milky Way has consumed, now moving on orphaned trajectories that don't follow the rules of the current spiral. And some rogue stars may not have formed in our galaxy at all. They are interlopers, born in long-dead galaxies or ancient fragments, swept up in the tides of collision and flung into our view. They cross paths with our instruments like strangers on a road, brief, bright, gone again. We think of galaxies as gravitational prisons, but they're more like living systems with permeable membranes. Stars can leave, matter can escape, and space beyond the galaxies isn't empty. It's just quiet. For now, these exiled stars remind us that even the grandest structures are not absolute, that gravity holds things until it doesn't, that not every sun stays where it was born. It's easy to imagine space as cold and lonely and still. But stars like these are messengers of chaos. They are motion incarnate. Their velocity is not just physical, it's narrative. They tell a story of rupture, of violence, of cosmic forces colliding in silence. We can't see the beginning, and we'll never see the end, but for a brief moment, we catch a star in flight. There's something deeply human about that, isn't there? The idea of leaving everything behind, not by choice, but by fate, of being pushed too close to something massive and mysterious and being sent away by its pull, of moving so fast you can't stop, can't go back, can't even look over your shoulder, just motion, just the long road between one galaxy and the next. And yet, they still shine. Even out there, in the cold between worlds, they shine. Not for anyone, not to be seen. Just because they are stars, and that's what stars do. Even in exile, we are used to thinking of the galaxy as a place of belonging, of systems, of cycles, of connection. But it's also a place of departures, of breakaways, of one-way journeys into the unknown. And scattered across the universe are stars that prove it, glowing dots that should have never left, but did, and they are still going. In the silence of deep time, There are destinies set in motion that no eye will witness, no voice will narrate, and no clock will chime. One of them is already underway, a slow, majestic drift written into the very structure of the night sky. If you could wait long enough, longer than species survive or stars endure, you would see our galaxy begin to change, not from within, but from without. Andromeda is coming. It's already visible, if you know where to look. A faint, smudged glow in the northern sky, stretching out across 220,000 light-years and sitting about 2.5 million light-years away from us. To the naked eye, it doesn't look like much. Just a dim patch, easily mistaken for a trick of your vision. But it's not still. It's not resting. Andromeda is moving toward us at roughly 400,000 kilometers per hour, a pace impossible to sense in a night or even a millennium, but relentless in its intent. It is the largest spiral galaxy in our local group, and it is on a collision course with the Milky Way. This is not science fiction. It is a scheduled event. In about 4.5 billion years, give or take, the kinds of uncertainties that vanish when measured in galactic time. Our galaxy and Andromeda will meet, not like ships gently passing, but like tides that cannot resist each other. This will not be an explosion, nor an annihilation. It will be a transformation. Galaxies don't collide the way solid objects do. They are mostly empty space. Stars are separated by such vast distances that even during this cosmic merger, the chance of two individual stars physically colliding is incredibly small. It's almost counterintuitive. You imagine chaos, suns crashing into suns, planets torn apart. But what actually happens is more elegant, more like choreography than catastrophe. Their shapes will distort first. The delicate spiral arms, so orderly and symmetrical now, will stretch and bend as tidal forces pull on them. The Milky Way will grow wings of stars. Andromeda will grow tails. Gravity will send stars into new orbits, some flung outward, others drawn closer. Clouds of gas will be compressed and stirred, triggering brilliant waves of star formation as the collision shocks ignite new light across both galaxies. For a time, the sky will shimmer with the birth of stars that would never have existed without the encounter. And then, slowly, the dance will settle. The two galaxies will spiral around one another, like partners caught in a gravity embrace, looping and folding together over the course of billions of years. Their cores will draw near. Their arms will lose definition. The sharp outlines of spirals will blur and round out. Eventually, the Milky Way and Andromeda will no longer be separate things. They will become one. A single, massive elliptical galaxy, smoother, older, quieter. A galaxy reborn, not through destruction, but through merger. It will shine with the blended light of 1 trillion stars, and it will hold within its core the memory of two great spirals that once circled each other in darkness. And Earth, if it still exists then, if it hasn't been scorched by the expanding sun, or left behind by a civilization grown strange, will find itself in a new sky. The night will no longer be marked by a single bright band of stars overhead. Instead, the heavens will spill over with tangled streams of light, double cores, and strange new constellations. The stars will not know they've moved, but any eye that could look up would see a changed universe. The name for this future galaxy doesn't exist yet, though some call it Milkomeda, a soft blend of both lineages. But names are small things compared to the scale of what's coming. What matters more is that this is part of the life of galaxies. They are not eternal in their shape. They are not untouched. They are constantly drawn toward one another, stitched together by the threads of gravity. The universe is expanding, yes, but locally. Within our group, gravity still wins. And when it does, galaxies collide. This isn't rare, it's ordinary. We see it in the sky all the time. Telescopes capture snapshots of galaxies mid-collision, twisting arcs, tidal tails, interlocked spirals locked in centuries-long embraces. These are not still images. They are glimpses of motion, paused by distance and time. And the Milky Way will become one of them. In some distant galaxy, an observer might one day peer out and see the light from our future merger. To them, we will be just another beautiful tangle of stars. There's a strange comfort in that, in knowing that even at this scale, nothing stays the same, that even galaxies are shaped by encounters, that identity in the cosmos is fluid. The Milky Way was built by mergers. Gaia Enceladus, Sagittarius, dozens of smaller galaxies whose stars now orbit within us, quiet and indistinguishable. And it will continue to grow, to change, to be transformed by contact. So when Andromeda arrives, it will not be an ending. It will be the next becoming. In the earliest moments of its life, before Earth existed, before planets coiled into orbits or oceans gathered their salt, the sun was not alone. It was one light among many, born from a shared cloud of gas and dust, surrounded by a loose gathering of siblings, stars of similar age, bound briefly by the gravity of their birth. These were the sun's first companions, forged in the same furnace, cradled by the same collapsing nebula. For a short time, in cosmic terms, they orbited together in a nursery of light, glowing warm and young, in a pocket of the galaxy that no longer exists as it once did. Stellar clusters like the one that birthed our sun are fleeting things. They emerge from dense molecular clouds, where threads of gas knot and twist into luminous beads. A cluster might hold hundreds, even thousands of stars, all igniting around the same time, their cores catching fire in a near simultaneous wave of fusion. But gravity among them is weak. The stars may form together, but they are never destined to stay. They drift apart slowly, then, more quickly, scattered by the tides of the galaxy, by close encounters, by the gravitational pull of larger objects nearby. Within a few 100 million years, the bonds are broken. The cluster dissolves, its members flung like dandelion seeds into the spiral arms. Our sun is one of those seeds. Alone now, with no known sibling close by, it orbits the galactic center in wide, unhurried circles, carrying in its core the memory of its beginnings. Somewhere out there, light years away, in every direction, its siblings still burn. Some may have flared into red giants, others may have cooled into white dwarfs. A few might host planets, perhaps even life, but none have been found yet with certainty. The sun's family is missing, not gone, just spread so far that they no longer recognize one another. Astronomers search for them, tracing chemical signatures in stars across the sky, looking for those with identical metallic fingerprints, an echo of the same primordial cloud. These stellar siblings are chemically unique, stamped with the same blend of elements, like children sharing a rare accent from a forgotten homeland. When one is found, it's not just a scientific discovery, it's a homecoming across billions of years. Some clusters are stronger, more tightly bound, and longer lived. Globular clusters are the ancient ones, the elders of the galaxy. They orbit the Milky Way like silent sentinels, far above and below the galactic plane, their stars packed together in dense spheres of light. Some hold hundreds of thousands of stars in a space only a few dozen light years across. These stars are old, some among the oldest in the galaxy, formed before the Milky Way even settled into its spiral shape. Their light is faint and reddish, their orbits long and looping. Time has not dissolved them. They endure. Looking into a globular cluster is like peering into the galaxy's memory. These clusters formed when the universe was still young, before heavy elements were common, before supernovae had sown the cosmos with metals. Their stars are pure in a way the sun is not. Metal, poor, ancient, stoic. They orbit in the halo, rarely crossing paths with the galactic disk, untouched by the noise and traffic of newer stars. They are survivors, and they are beautiful. But even they will not last forever. Over immense spans of time, even the tightest globular clusters begin to evaporate. Stars are stripped away by gravitational nudges, by the pull of the Milky Way's mass, by the constant churn of motion that defines galactic life. A cluster is not a static sculpture. It is a dynamic, living system, breathing stars in and out, slowly dissolving into the field of the galaxy. And so, the Milky Way is filled with ghosts, not the kind that haunt, but the kind that drift. Former clusters, long since dispersed, now form part of the smooth stellar background. Their members orbit, independently, unaware of their shared origin. The galaxy is a graveyard of dissolved families, but each star remembers, in its atoms, in its composition. And perhaps one day, long after humanity is gone, someone else will find them, reunite them, trace their lineage back to a single cradle. The story of clusters is a story of both closeness and loss. Stars begin together, as siblings, tightly held, warmed by proximity. But they are born with motion, with momentum, with individual paths written into their birth. That motion ensures they cannot remain together. It is not betrayal, it is design. In a way, it mirrors so many of our own stories: brief gatherings, shared beginnings, inevitable partings. And yet, from that brief union, galaxies are shaped. The spiral arms are written by the births and deaths of clustered stars. The metal that forms planets is forged in the cores of stars born in clusters. Even the elements in your body, your calcium, your iron, your oxygen, were once part of a cluster's story. You carry the dust of star nurseries in your blood. So when you look up at the sky and see stars scattered like random specks, remember that many of them once knew each other, once drifted side by side in the same celestial nursery. Some still do. There are young open clusters visible even now, like the Pleiades, bright and close, a group of young stars still holding hands, not yet pulled apart by the galaxy's tides, but most are already gone, or changed, or wandering, like the sun, still burning, still moving, still remembering. Far beyond the familiar spiral arms, beyond the glowing lanes of starlight and the warm churn of star birth and dust, the galaxy stretches out into something quieter, colder, and stranger. It fades not into emptiness, but into a halo, not a ring of light, but a vast, diffuse sphere that envelops the Milky Way like breath held in the dark. You can't see it with your eyes. You can't even trace its edges clearly with instruments, but it's there, surrounding the galaxy like a ghost walking the boundary between presence and absence. And within it, mysteries drift. The galactic halo is not where the light lives, it's where the light escapes. Sparse, ancient, and faint, it holds the oldest stars our galaxy remembers. They orbit not in neat spirals, but in loose, looping arcs that carry them far above and below the disk. Some belong to globular clusters, tightly packed swarms that have survived since before the Milky Way's spiral arms first formed. Others are solitary, old, metal-poor stars moving like relics through the void, untouched by the chaos of younger galactic neighborhoods. They are time travelers, still burning with the low, steady glow of ancient fusion, carrying in their atmospheres the undisturbed memory of the early universe. And there are streams, not streams of water or gas, but of stars, thin, fragile trails stretching across hundreds of light years. These are the remnants of smaller galaxies that the Milky Way once consumed. Like breadcrumbs scattered through the dark, they mark the path of something that no longer exists, shredded by gravity and absorbed into the galactic body. You can trace them like fingerprints, curving through the halo in elegant arcs, frozen in the process of falling apart. They tell stories without words, stories of mergers, of motion, of galaxies brought close enough to lose themselves. Somewhere in this halo, planets may wander without stars, born in violent systems or torn loose by gravitational scuffles. These rogue planets drift in silence, unlit and unclaimed. They do not orbit, they do not warm, they simply move, alone in the dark, worlds without suns, lost in the vastness of the galaxy's edge. We've never seen them directly. They give off no light, no signal we can easily catch. But their gravity tugs faintly. Their presence is inferred in the slight deflections of other bodies. They are ghosts of formation, planets, exiled from their systems, wrapped now in the cold of space and time. Dark matter, too, may reside here in abundance. Though invisible, it shapes the halo's structure, its gravitational grip holding the galaxy together. Without the dark halo, massive, unseen, extending far beyond the stars we know, the spiral arms would not survive. They would spin themselves apart like petals in a storm. But something holds them, something vast, spherical, and transparent. The halo is that invisible skeleton, a quiet scaffold of mass, anchoring the galaxy in place. And yet, despite all it holds, the halo is not dense. It's the loneliest region of the Milky Way, where stars are separated by immense stretches of blackness, where light barely flickers and the silence is profound. It doesn't glow, it doesn't churn, it watches. While the galactic disk teems with supernovae, stellar nurseries, and orbiting worlds, the halo moves with an eerie serenity, a slow tidal dance shaped by the memory of past collisions and future fates. We live far from this region, deep within the galaxy's luminous disk, cushioned by stars and shielded by proximity. But we are part of it still. The halo envelops everything, our entire solar system, spinning gently in its spiral lane, is suspended within a vast sphere we can barely measure. It's not something we pass through, it's something we're already inside. The edges of the halo are hard to define. They don't end so much as fade. Like twilight bleeding into night, the stars become fewer, the streams more delicate, the silence more absolute. Eventually, the pull of our galaxy gives way to the pull of others. The local group, a loose collection of galaxies drifting together in the cosmic ocean, begins where the halo thins out. There's no border, only distance. And yet, it's in this liminal space, this in-between, that the story of the Milky Way becomes most profound. Because here, on the edge of what we can see and measure, is where the galaxy reveals its memory, not in bright, burning starlight, but in remnants, in traces, in the long, slow motion of stars no one will ever see with the naked eye. To look into the halo is to look into a mirror tilted slightly backward in time. It shows us the galaxy as it once was, raw, chaotic, assembling itself from smaller pieces. It shows us where it came from, how it grew, what it consumed, and it whispers of what still moves through the dark. Stars that were not born here, planets that don't belong, masses we cannot see but that weigh everything down. So much of the galaxy's truth is hidden, not because it resists discovery, but because it lives in a register beyond our senses. The halo humbles us, not with brilliance, but with absence, not with answers, but with outlines. It is the place where light fades and wonder grows. And while we may never visit it, never set eyes on its loneliest stars, or touch the rogue worlds drifting silently across it, we can still feel its shape. It surrounds us, holds us, reminds us that even in emptiness, there is structure. Even in silence, there is motion. Even at the edge of knowing, there is still a galaxy. When a star dies in silence, it fades gently, cooling over eons into a dense cinder of memory. But some stars don't go quietly. Some end with violence, sudden, radiant, catastrophic. These are the supernovae, the colossal deaths that roar across the galaxy like thunder, unmaking themselves in a burst of light so bright it can briefly outshine an entire galaxy. In that moment, a single star becomes a storm, its matter hurled outward, its core collapsed inward, its legacy carved into the fabric of space. The Milky Way has been shaped by these events, not just scarred, but sculpted. Each supernova reshuffles its surroundings, punching holes in the interstellar medium, sweeping vast bubbles of gas and dust into intricate new patterns. The violence is creative. The destruction is fertile. In their death, these stars seed the future. What remains is not just absence, but possibility. The elements that make you, carbon, calcium, iron, were born in these cosmic endings. They were not present at the beginning of the universe. The early cosmos was made mostly of hydrogen and helium, light gases floating through emptiness. Heavy elements, the ones that form planets and people and oceans and bones, had to be forged in fire. Inside stars, nuclear fusion builds heavier atoms, one by one, pushing upward through the periodic table. But it's in the moment of collapse, when a massive star can no longer hold itself up, that the heaviest elements are born. In that brief, ferocious breath of the supernova, gold is made. Platinum is formed. Uranium emerges. The ring on your finger may be older than the Earth, older than the Sun. It may be the cooled memory of a supernova that exploded before our solar system was born. The atoms it contains traveled light years through space, folded into clouds of dust that collapsed into a young star and its orbiting planets. You wear a relic of stellar death, a fragment of violent beauty, and so does every cell in your body. Supernovae are not random. They happen in patterns, in places where stars live fast and die young. Massive stars, short-lived and powerful, burn through their fuel in just a few million years. When the balance between gravity and radiation collapses, the core implodes. Neutrinos stream outward in unthinkable numbers. Shock waves erupt. Outer layers are blasted into space at 1/10 the speed of light. What's left may be a neutron star, a city-sized object with the mass of the sun, or, if massive enough, a black hole. The shock wave from a supernova doesn't just scatter atoms. It presses against surrounding clouds of gas, compressing them, stirring them, lighting the fuse for something new. These waves can trigger the birth of new stars, pushing dense regions of gas past the threshold where gravity takes hold. In this way, a star's death is also a kind of genesis. One star ends, and dozens more may begin. The galaxy cycles itself through fire and ash. We've seen this echo of renewal in places like the Crab Nebula, a swirling relic of a supernova that lit Earth's sky nearly 1,000 years ago. Ancient astronomers saw it with the naked eye, a new star where none had been, bright even in daylight. Today, we see what's left, tangled filaments of dust and gas, glowing softly, moving outward in slow, ghostly spirals. At its center, a pulsar spins, the crushed heart of the dead star still beating with radiation. It flashes with eerie precision, like a lighthouse adrift in space, but many supernovae go unseen. In the Milky Way, dense dust hides much of the action. We can't always witness the moment itself, but we see the aftershocks. X-ray telescopes trace the outlines of bubbles. Infrared maps catch the heat of expanding shells. We know there are hundreds of remnants scattered throughout the galaxy, quiet now but once unimaginably loud. There's something haunting about the idea that we live among the debris of ancient explosions, that the sky we see, calm, unchanging, is a palimpsest of detonation. Every star you see tonight is surrounded by echoes. Somewhere, a supernova carved out space nearby, long ago, and now its elements drift invisibly through the interstellar sea. Even the space between stars is not empty. It is rich with dust, fine, metallic, carbon-laced grains suspended in the cold. This dust is not waste. It is potential. It becomes the scaffolding of new worlds. It is swept into planetary disks. It coalesces into moons and mountains. It becomes atmosphere and water and life. It becomes you. Supernovae remind us that permanence is an illusion. Everything is motion. Everything is change. The star that gives us light now will not last forever. One day, far in the future, it too will die, though not with a supernova's fury. It will shed its outer layers, gently, leaving behind a white dwarf, a different kind of quiet end. But it will have its moment, and its matter will return to the galaxy. And maybe one day, billions of years from now, something new will form from it. A new star, a new system, a new chance. So the next time you look at the night sky, try to imagine not just the points of light, but the explosions between them. The absent stars, the ones that lived and died and left their legacy behind in every breath you take. The galaxy is not just a place of serene rotation. It is alive with fire, shaped by detonation, guided by the brief, furious lives of stars too massive to last. And somewhere in that swirling, expanding cloud of consequence, something begins again. The galaxy is not silent. It only seems that way because your ears are tuned to the wrong instrument. If you could step outside the narrow band of human sound, if you could tune yourself to the frequencies of starlight and radiation and magnetic shiver, you'd find that space is filled with a kind of music, not made of melody, but of rhythm and pulse and invisible song. This is the Milky Way's silent music, and you are inside it every second of your life. Right now, cosmic rays are passing through your body, not one or two, but thousands. High-energy particles born in cataclysms, in supernovae, in black hole jets, in violent unknowns, are tearing across the galaxy at near the speed of light. Most are protons, some are electrons, a few are heavier. When they strike Earth's atmosphere, they burst into cascades, tiny showers of particles that whisper against mountaintops and satellites. We don't feel them, not because they are weak, but because we are not built to sense them. Their music is in a different key. Above us, scattered across the galaxy, like metronomes, are pulsars. These are the remnants of massive stars that once exploded in fire and fury, leaving behind neutron stars. Dense, collapsed cores no wider than a city, but heavier than the sun. They spin, some hundreds of times per second, and their magnetic fields funnel beams of radiation like lighthouse beams through the void. If Earth is aligned just right, we hear them tick, not with sound, but with radio pulses, so regular and precise they make our atomic clocks look clumsy. They are the ticking hearts of dead stars. Somewhere out there, a pulsar is spinning 716 times every second. Another ticks slower, once every few seconds, like a breath held for eons. Some are so stable that physicists have used them to test the laws of gravity. Others glitch, sudden, tiny hiccups in their rhythm, the internal shudder of matter packed too tightly for comfort. When a pulsar glitches, it sends a tremor across the galaxy, and somewhere, a dish on Earth listens. But not all of the galaxy's music is rhythmic. Some of it is almost silent, in a way that feels holy. Neutrinos, in particles so light they almost don't exist, pass through you in uncountable numbers. Every second, trillions stream through your body, through your hands, your skull, your bones. They come from the sun, from distant stars, from the memory of the Big Bang itself. They don't bounce off you, don't stop, don't scatter. They pass through entire planets as if they weren't there at all. Only a few ever interact, and even those do so quietly in dark underground tanks of pure water or heavy metals, where detectors wait like monks in stone silence, hoping for a single flash. You are a crossroads for ghosts of the universe. You are soaked in starlight you cannot see, surrounded by messengers you will never hear. But some of the music does reach us. If we know how to listen, radio waves stretch across the galaxy, gentle and wide, carrying stories that light cannot. Dust clouds block visible light, so do gas and shadow. But radio can slip through, revealing the shape of things hidden to the eye. With radio telescopes, we can map the spiral arms of the Milky Way, trace the structure of hydrogen, listen to the chatter of quasars and galaxies and drifting stars. It's a different kind of seeing, more patient, more forgiving. The center of the galaxy is loud in radio. Sagittarius A*, our central black hole, hums in frequencies we can't hear but can translate. In radio, we've seen flares from its edge, bursts of energy that ripple through surrounding clouds. We've watched jets rise from other galaxies, extending for thousands of light years, bright in radio but silent in everything else. There are mysteries that exist only in this form. Radio bursts that appear and vanish in milliseconds. Fast radio bursts that stutter with no known cause. Some repeat, some don't. Some come from galaxies millions of light years away, others from nearby. All of them whisper in a language we haven't fully learned. In between these known notes are frequencies filled with background, the cosmic microwave background, the faint hiss of the Big Bang, is still with us, echoing across the sky. It's not loud, but it's constant, the afterglow of everything, a reminder that time itself is soaked in signal. We tend to think of the galaxy as dark and quiet, but that's only because we rely too heavily on our eyes, on the narrow slit of color we call visible light. The real Milky Way is ablaze with energy, roaring and ticking and whispering all at once across wavelengths we never evolved to see. Infrared shows the warmth of hidden stars. X-rays reveal the shock waves of collapsed ones. Gamma rays scream from dying black holes. Every layer of the galaxy tells a different story, and all of them are happening at once. So when you stand outside at night and everything feels still, try to imagine what you're actually standing in. Not quiet, but music. Not emptiness, but fullness. You are inside a symphony of particles and waves, rhythms and pulses, flashes and flows. You are not separate from it. You are soaked in it. Your brain was built from atoms that once rang with the heat of stars, that once danced in radiation storms, that now echo with distant pulses. The galaxy does not need us to hear it. It has been singing since before we were born. But once you realize that it's singing, you can't unhear it. And that might be the most beautiful sound of all. Out there in the dark, far beyond the reach of our eyes, planets are everywhere. They do not announce themselves. They do not shimmer with their own light. But they are there, quietly orbiting, gently spinning, waiting in patient procession around stars we'll never see. For most of human history, we believed planets were rare, special, that maybe our solar system was a fluke. But the universe, it turns out, builds worlds easily. It builds them as casually as wind shapes, sand dunes, or rivers carve valleys. Stars form with companions, and those companions are often planets. It starts in dust. A collapsing cloud of gas forms a star, hot and bright at its center, and all around it, the leftovers swirl, a wide, flat disk of dust and ice and rock. Within that disk, matter clumps together, drawn by gravity, sticking and gathering, turning tiny grains into boulders, boulders into mountains, mountains into planets. Some worlds form close to the star, others far away. Some are gas giants with swirling storms and invisible cores. Others are rocky, battered, cracked with ancient scars. And some are small and strange and molten or frozen or ringed with atmosphere too thick to breathe. But they are everywhere. We now know that most stars, maybe even nearly all stars, have planets. It's not an exception. It's the rule. Every point of light you've ever seen in the night sky is likely to be orbited by its own secret system, its own procession of silent companions. Solar systems are not rare ornaments in the galaxy's design. They are woven into its structure like thread through a loom. In every direction, across every distance, worlds are circling, and not just one or two at a time. Some stars host dozens. Some systems are tightly packed, with planets closer to their star than Mercury is to ours. Others are wide and spacious, with long, slow orbits that take centuries to complete. There are hot Jupiters, orbiting so close they whip around in days. There are super-Earths, rocky and vast. There are planets with rings, with moons, with storms larger than Earth, with oceans deeper than any trench we've known. Some planets likely have skies stained green by chemicals we've never seen in our own air. Some may have magnetic fields that crackle and hum. Others may be completely dead, frozen, barren, with nothing left to change. And then there are the wanderers. Not all planets stay with their stars. Some are born in chaos, kicked away in early gravitational battles, ejected from their systems like forgotten children. Others may drift free after their stars die, released from orbit, cast into the galaxy like flotsam on a black sea. These are rogue planets, orphans in the dark. They don't orbit anything. They don't shine. But they drift through the Milky Way by the billions, invisible to us, unless they briefly pass in front of a distant star and bend its light with gravity. Some may be warm with radioactive heat, wrapped in thick atmospheres that trap their inner warmth like blankets. Others may be frozen solid, but they move, slowly, silently, without a tether. A rogue planet could be passing near our solar system right now, and we might never know. Think about that. A world, vast and ancient and utterly alien, sailing quietly through the dark between stars. No sun, no sky, just endless night and the memory of where it once belonged. Even among planets with stars, the diversity is overwhelming. Some orbit twin suns, dancing between them in paths we once thought impossible. Others are tilted sideways, their poles bathed in sunlight for years at a time. Some are tidally locked, one side scorched by endless day, the other trapped in eternal night. There are planets where it rains molten glass sideways, planets with atmospheres of methane and seas of hydrocarbons, planets where the air glows purple, or where lightning never stops. Some, maybe, have land, water, clouds, and maybe, just maybe, life. We do not know how rare life is, but we do know that planets are not rare, and life needs a place to begin. So when you lie beneath the sky and count stars, remember that what you're really counting are homes. Not just the glowing cores of distant fusion engines, but the unseen families that gather around them. You are looking at systems, at neighborhoods, at entire collections of planets that rise and fall and orbit and shift in ways we're just beginning to imagine. There are solar systems out there being born right now. Disks of dust still warm from collapse, where baby planets are carving rings in the material, shepherding debris with their gravity, shaping the future layout of their worlds. We've seen these disks in infrared, captured their glow, watched the dark paths cut by growing planets we cannot yet resolve. It's like watching footprints in sand before you see the feet that made them. There are also systems dying, stars swelling into red giants, consuming the inner worlds, boiling away oceans, swallowing moons. And around the edges of these fading systems, cold, distant planets wait in slow orbits, holding on to their darkness a little longer. Everything in the galaxy has a lifespan. Stars, planets, orbits, even solar systems are temporary arrangements. But the pattern itself continues. The galaxy builds, it reshapes, it recycles, and always, always, it leaves behind worlds. Maybe that's what makes the Milky Way feel so alive. It's not just a collection of stars. It's a nursery, a sculptor, a storyteller, a mapmaker of orbits and gravity and time. And on one small planet, in one ordinary system, in one quiet arm of one galaxy among billions, someone is listening, wondering, dreaming of the worlds they'll never touch but can still imagine. In the end, that may be the closest thing we have to magic. Not that planets exist, but that we can know they do. The Milky Way is not finished. It may seem, from where we sit, like a completed thing, a glittering wheel of stars frozen in a quiet ballet, its arms unfurled across the dark like the petals of some ancient cosmic bloom. But that image is a snapshot, a single frame in a film that plays out over billions of years. Because the truth is, our galaxy is still becoming, it is still changing, still folding itself forward into futures we'll never live to see. Star formation, for instance, has slowed but not stopped. Once, long ago, the galaxy was a furnace of creation. It burned through its gas with youthful hunger, collapsing clouds by the millions into stars so rapidly that light filled the void with almost reckless abandon. Now, the pace is gentler, the clouds are fewer, the frenzy has eased. But in dark corners, in cold folds of dust and shadow, stars are still being born, quietly, steadily. The galaxy breathes on, its lungs not yet empty. Even now, new material continues to flow in from the greater universe. From the vast threads of the cosmic web, filaments of intergalactic gas funnel into the Milky Way's halo, drawn by gravity, tugged by tides, invisible to the eye. Some of this gas slips into the disk, joining the great reservoir that fuels new stars. Some swirls above the galactic plane, forming clouds that may fall inward in the future, like rain returning to the soil. The galaxy is not a sealed system. It is porous, hungry, and always in conversation with the cosmos beyond its edges. We often imagine galaxies as isolated islands, but they are not. They are part of the larger structure of the universe, connected by gravity, by flow, by exchange. The Milky Way was built from such interactions, from collisions and mergers and infall, and that building process is still underway. Streams of stars, like luminous veins, still arc across the sky, remnants of smaller galaxies that ventured too close and were shredded into spirals. Some of that starlight now belongs to us, absorbed into the halo, folded into the arms, woven into the Milky Way's shape as if it had always been there. And yet the shape itself is temporary. What we see today, ATS. This particular spiral, this balance of gas and stars and motion, is not the galaxy's final form. The stars continue to move, pulled by gravity, nudged by density waves, reshaped by time. The spiral arms shift, the disk warps, the central bulge pulses and rotates, its stars in fast orbits around the massive black hole at the core. Even the position of our solar system, drifting slowly along its orbit, is part of that endless rearrangement. We are not sitting still in space. We are swimming through a living current. That motion gives rise to change. And the change is not just mechanical, it is chemical. Every generation of stars leaves behind something new. The first stars formed from hydrogen and helium alone, clean and bright and brief. When they died, they scattered heavier elements into space: carbon, oxygen, iron, gold. The next generation formed from that enriched material, and when those stars died, they seeded the clouds again. And so on, layer by layer, the galaxy has been flavored by its own dead. By now, we live in a Milky Way that carries the history of its ancestors in every cloud and planet and pulse of light. We are made of that history. You, sitting there quietly, listening, breathing. You are built from atoms, forged in a dozen long-dead stars. And those stars were born in clouds shaped by supernovae before them, which came from earlier stars still, each generation layering its legacy into the next. In that sense, you are part of the galaxy's growth, a product of its becoming, not separate from the story, but one line in it. What we see, when we look at the Milky Way, is not just a galaxy. It is a moment, a particular arrangement of matter and motion that exists for a time before becoming something else. Billions of years from now, the stars we know will have drifted, exploded, dimmed, collapsed. New stars will shine where none do now. The arms will be stretched, twisted, reborn. Gas will be spent. More of the galaxy will go dark. But even then, it will not be over. There will be echoes, embers, light still traveling across space long after the fires have gone out. And even today, when we call the galaxy ours, we are only borrowing it for a breath of time. The Milky Way does not know we are here. It does not care. But we can care. We can notice. We can marvel. Because there is beauty in watching something that is still in the act of becoming, something not yet done, not yet perfect, and perhaps never meant to be. That is what it means to live in a galaxy like this one, to float inside something ancient that is still building itself, to exist in the pause between what was and what will be, and to know that every moment, every motion, every quiet drift of starlight is just one more frame in a story that is still unfolding, a story that includes you, a story that is, even now, being written in light. There are secrets hidden in the way stars move, quiet, patient secrets that never speak but always point. Look long enough and you'll see them. The strange orbits, the unexpected tilts, the loops that don't match the spiral's swirl. Not every star plays by the rules. Some have wandered into the galaxy from faraway places. Some are ancient survivors of events so old they've left no other trace. Some don't orbit the way most do. Not in smooth circles, not in obedient paths. Some move backward. These retrograde stars are rare, but they are real. Like salmon swimming upstream in a river of light, they push against the flow of the galaxy's rotation, and they don't do it for drama or defiance. They do it because once, long ago, something set them on that path. A collision, a merger, a swallowed galaxy, a ghost of gravity, long since faded, that tugged them into orbits that defy the neat simplicity of spirals. These stars carry the memory of chaos in their motion. They are history made visible, relics not of what is, but of what happened. Other stars move not backward but sideways, upward, downward, on tilted paths that cut across the flatness of the galactic plane. Some drift in wide ellipses, swinging far from the center, arcing out into the halo, then diving back in. These stars are messengers too, tracing routes that speak of a galaxy shaped by violence and growth. No two orbits are quite the same, and when you look at enough of them together, thousands, millions, you begin to see patterns emerge, waves, streams, structures that aren't visible in light, but only in motion. This is what astronomers call galactic archaeology, not with shovels or dust brushes, but with telescopes and algorithms, not by digging, but by watching, by measuring how fast a star is moving and in what direction, by comparing its speed to its brightness, its composition, its position in the sky. Motion becomes a map. Each orbit is a trail of breadcrumbs leading backward through time. When we find a cluster of stars all moving together, maybe looping high above the disk or spiraling inward from the edge, we know they once shared something, a birthplace, a home, a journey. Some of these groups are the remnants of old star clusters, now stretched into ribbons by the galaxy's tides. Others are the bones of galaxies long ago devoured. We can't see those galaxies anymore. Their shapes are gone, their cores dissolved. But their stars remember. They move as they did when they were together, even if they've been scattered across the sky. Their shared motion is a fingerprint, a whisper of something once whole. It's not just about where stars are, but how they move. The Milky Way's spiral arms are shaped not only by brightness or density, but by the synchronized flow of stars and gas. These arms are not fixed structures, but waves of movement, patterns of traffic in the vast, slow dance of the disk. Stars enter and leave the arms all the time. The arms themselves are places where orbits compress, where motion clusters, like cars slowing down on a highway curve. When you watch the movement of stars over millions of years, the arms ripple like silk. And beneath it all, beneath the light, beneath the spiral, is something even more mysterious. Dark matter. We can't see it, but we can see what it does. It pulls. It tugs. It shapes the orbits of stars that lie too far from the center to be held by gravity alone. If the galaxy were made only of the stars and gas we can see, it would fall apart. The outer stars would fly off like sparks from a wheel. But they don't. They hold, they circle, and their motion tells us that something invisible is holding them in place. In this way, motion becomes a shadow map, a way to trace what can't be seen, a whisper of structure without structure. We watch the wobble of stars and infer the presence of a halo, a scaffolding made not of matter but of effect. The stars move as if it's there, and so we believe it is. Even here, in our own solar neighborhood, motion holds secrets. Some stars near us are moving too fast, too slow, or in odd directions. These may be stars from elsewhere, immigrants from another galaxy, or survivors of an ancient collision. One of them, known as Gaia Enceladus, left behind a tidal wave of stars still rolling through the Milky Way. We see them not because they look different, but because they move differently. They are the fossil wakes of a galactic shipwreck. In the end, all of this, the spirals, the streams, the retrogrades, becomes a kind of music, a vast, silent symphony played across billions of years, each star a note, its orbit, a phrase. Together, they tell a story too slow for human ears, but we can still read it. We can still feel the rhythm in the way stars spin and rise and fall. And you, listening now, are part of that song. Our sun, too, follows a path, a slow, looping orbit around the center, tilted slightly above the plane. It drifts gently through the galactic tide, surrounded by its planets, like a candle ringed by moths. We move through the galaxy not as passengers, but as participants. Our own orbit is a line in that larger story, written not in ink, but in motion. The stars remember what we can't, and they tell us, if we listen, you are here, not metaphorically, not poetically, but literally, physically, cosmically, here, floating in the spiral arms of a galaxy so vast it defies simple comprehension, and yet so intimate it cradles you like breath in a chest. The Milky Way is not just the backdrop of our lives, it is our home, our womb, our inheritance, and every moment you've ever lived has unfolded in the curl of one of its arms, wrapped gently around the center like a child around a parent's leg. But this is no ordinary address. The place you inhabit is a turning, glowing river of stars, more than 100,000 light-years wide. Its core hums with energy and gravity, where stars dance wildly around an unseen giant. Its outer reaches stretch toward the darkness, thin and quiet, scattered with forgotten clusters and dim red stars nearing the ends of their lives. And in between, in a small, relatively calm spur off one of the grand arms, there is us, a sun, a few planets, a single, silent blue world tucked safely in the folds of an immense, rotating wheel of light. From Earth, you cannot look down on the galaxy. You cannot step back to see the whole. There is no balcony above the Milky Way, no outside vantage. You are embedded in it, like a cell inside a body, sensing only what flows past. We see it edge on, through the thickest part of its dust and stars, like staring. Through the long grain of a wooden table, the band of milky light that curves across the summer sky is not some distant object. It's the galaxy from within, the inside of a structure so vast that we forget we're part of it. But you are. The starlight that reaches your eyes at night has been traveling for tens, hundreds, even thousands of years. Each photon, an ancient traveler finally arriving. Many of those stars are already gone. Some are only just now being born. Most you'll never see. Not because they aren't there, but because the light they emit is hidden, blocked by dust, dimmed by time, shifted into wavelengths your eyes were never meant to catch. You live in the visible sliver of a universe made mostly of the unseen. And yet somehow, that sliver is enough to fill a night with wonder. But even more quietly astonishing is this: you are made of the same stuff as those stars. Your blood carries iron forged in the heart of a long-dead sun, the calcium in your teeth, the oxygen in your lungs, the carbon that threads through every cell of your body. All of it came from the remnants of stars that exploded billions of years ago. Your body is a map of past supernovae, a vessel of recycled light. You are not just in the galaxy, you are of it. This truth is both humbling and strange. It places you in the story of things so vast you cannot hold them in your mind, but it also makes you part of that story in the most intimate way. When you breathe, you draw in molecules born from the slow cooling of gas clouds spiraling through the Milky Way. When you blink, you are a fragment of galactic dust, briefly awake, briefly aware. And when you sleep, you do so in the arms of something unimaginably large, not as a speck in the void, but as a thread in its fabric. It's easy, sometimes, to feel small, to look up and feel overwhelmed by the scale of it all, to think that because you are not ancient or massive or bright, you do not matter. But galaxies are not built only of giants. They are made of everything, of dim stars and lonely planets and drifting clouds, of pulses and pauses, of things seen and things missed. You are not an outsider looking in. You are inside it. You are the galaxy, thinking about itself. The Milky Way is still becoming, still evolving. New stars are forming. Old ones are dying. Clouds collapse, and dust spins into disks, and planets begin to coalesce around fledgling suns. And among those countless systems, on one small world, at the edge of one quiet spiral arm, someone like you is listening and wondering, maybe with eyes closed, maybe with questions that have no easy answer, maybe with a heart full of thoughts too soft to name. But even that is part of the pattern. Galaxies are not only measured in mass or light, but in stories. And yours, however fleeting, however quiet, is here now, in this moment, in this orbit, in this breath. One voice among billions, whispering in the dark. You are here.